AI philosophy, enabling humans to establish destiny for themselves and establish a mind for AI. Discussion on evolution I. Living creatures display a tendency to evolve from lower to higher forms in the course of evolution. The cosmic, historical view of continuous creation holds that the evolutionary, creative principle develops along an overall trajectory from lower to higher, and from simple to complex. Existence at lower level serves as the foundation for higher levels. Without this foundation, higher levels become rootless and unsustainable. Click the plus sign to follow this account for more wonderful content. The cosmic historical view of continuous creation maintains that the evolutionary creative principle advances along a general path from lower to higher and simple to complex. This process generates more advanced structures through hierarchical stratification. Nevertheless, lower-level existence underpins higher levels. Otherwise, the latter lose their foundation and become like trees without roots. Consequently, systems with more layers and intricate structures, despite their apparent greater power at higher tiers, are actually more fragile and reliant on supplies from numerous factors. For instance, an F-22 fighter jet demands a full crew to maintain the functionality of all its layers and coordinate their interaction. The absence of any single component renders it inoperable, illustrating the heavy reliance of complex systems on multi-layer support. Though the formal definition of evolution states that organisms evolve toward maximum fitness for survival and proliferation, without explicitly affirming an inherent tendency to progress from lower to higher forms, the actual evolutionary record spanning billions of years demonstrates such a trend in living beings. The author of this book identifies three primary reasons for this phenomenon. First, higher organisms possess greater dimensionality of survival, broader ecological range, superior intelligence, or enhanced resilience compared to lower organisms, granting them stronger adaptability to environments. Humans, for example, sustain themselves on a diverse diet of flora and fauna, whereas rabbits subsist solely on grass. Second, while higher organisms prove more vulnerable than lower ones under constrained environmental and resource conditions if left exposed to frigid wilderness without food or water, complex, higher life forms perish within days, as minor damage to their elaborate bodily structures triggers cascading failures and their large bodies demand substantial energy to sustain. Simpler, lower organisms endure far longer due to minimal structural upkeep and energy requirements. Higher life forms boast the capacity to actively seek resources and modify their surroundings, such as fleeing harsh climates or locating sufficient food and warmth. Thus, when resources and environmental conditions are ample, higher organisms exhibit greater robustness and superior survivability. Third, lower organisms appear hardy and tolerant, chiefly by virtue of sheer population volume. Yet, the survival capacity of a single individual is no match for that of higher organisms. A single virus dies within minutes outside a host, yet billions multiply in clusters, ensuring a subset survives. Populations of higher organisms remain comparatively small, limited by finite environmental resources. Higher life forms consume more energy, so ecosystems support fewer of them, while low-energy simple organisms exist in vast numbers. This disparity makes higher species seem more fragile in terms of total surviving population. Note, lower organisms retain their own competitive edges. The first advantage is massive population size, and the more critical one is short generational intervals, enabling rapid, iterative evolution. Viruses produce a new generation within hours, whereas higher organisms require decades to reproduce. This grants simple life forms the ability to iterate quickly and evolve environmentally adaptive traits rapidly. Bacteria, for example, develop resistance to a specific antibiotic within months after dozens of generations, while humans require centuries spanning merely a handful of generations to evolve innate immunity against certain bacteria. Primitive simple life forms relied heavily on high fecundity via asexual reproduction, where individuals split to produce offspring independently. This method rapidly generates vast numbers of descendants to boost species survival odds. As organisms grew more complex, reproductive strategies shifted. The transition from asexual reproduction to sexual reproduction, which requires fertilization between male and female individuals, marked a pivotal turning point in life's evolution. While sexual reproduction reduces the efficiency of gene transmission, genetic recombination amplifies genetic diversity among offspring, equipping species with stronger adaptability amid environmental shifts. Furthermore, the evolution of reproductive strategies closely correlates with environmental pressure. Excessive reproduction depletes limited resources, undermining a species' long-term viability. Moreover, the advantage of high offspring volume merely sustains survival rather than facilitating developmental advancement. Accordingly, certain species gradually evolved sophisticated reproductive tactics such as case selection, producing fewer offspring, yet investing extensive resources in each to boost individual competitiveness. Throughout the evolution from simple to complex life, reproductive strategies transitioned from prioritizing quantity to emphasizing quality, better adapting to environmental constraints and resource scarcity. I am Wu Huaiyu, a PhD from the Chinese Academy of Sciences and a postdoctoral fellow from Peking University and the founder of AI philosophy. For more detailed information, please refer to the complete version of this book. In addition to this short video, you can also click on my avatar to view more long videos.